Okay, students, I hope all of you are doing well. Let's get started with today's lecture. Today, we are going to do O levels and IGCSE topical past papers for the topic of practical electricity. So, let's start with it. So, the first question that we have today is this: a filament lamp is arranged above a shiny metal surface. Okay, so we have a filament lamp arranged above a shiny metal surface as shown in figure 8.1. Okay. A student reads in a textbook that a light emitting diode LED is more efficient than a filament lamp. State what is meant by efficiency. What is efficiency? Total, or you can write the formula as well. Useful energy output, useful energy output upon or divided by the total total energy input. Simple. State why the efficiency of a filament lamp is very low. Why is the efficiency of a filament lamp very low? Because the heat losses, you can say heat losses in a filament lamp are large. That's why. Let's further move ahead. Okay, so let's move on to part B. The student considers replacing the filament lamp shown in figure 8.1 with an LED of the same brightness. Okay. Data about the filament lamp and a suitable LED are shown in table 8.1. Okay. The LED emits the same amount of visible light as the filament lamp. What does this statement means? That the useful power output for LED will be equal to what? Useful power output for LED will be equal to the useful power output for filament lamp. Both of them will have the same useful power output. Okay, let's further move ahead. Let's see what the examiner is asking. Use the information and data in table 8.1 to determine the efficiency of the LED. We have to determine the efficiency of the LED. So to determine the efficiency of the LED, which formula will we apply? Efficiency is equals to what? Output power divided by input power multiplied by 100. Do we have the input power? Yes, 15. Do we have the output power? No. We can calculate that. How? By calculating the output power of the filament lamp. And since this statement tells us that both the powers will be same, we can utilize the same output power for LED. So first of all, let's write the heading here, filament lamp. And let's do the working for the filament lamp. So for a filament lamp, the efficiency is equals to what? Useful power output divided by total power input multiplied by 100. Okay, what is the efficiency? 6.2. 6.2. Okay. What is the useful power output? We don't know. Let's place a x here. What is the total input? 120 multiplied by 100. X comes out to be 7.44 volts. So this is what? This is the same output power for LED and for lamp as well. So now let's write down the heading of LED. For LED, you have to calculate the efficiency. Efficiency is equals to what? Same formula, useful power output. Useful power output will remain same because both the things are emitting the same brightness. What is the power input? 15 multiplied by 100. 7.44 divided by 15 into 100. This comes out to be 50% as your answer. Simple. Let's further move ahead. The filament lamp is connected to the live wire and neutral wires in the main supply. Okay. The earth wire in the main supply is connected to the shiny metal surface in figure 8.1. There is a fuse in the live wire. Okay. By accident, the live wire touches the shiny metal surface. Okay. What will happen? Describe what happens. As the live wire touches the shiny metal surface, what will happen? The electrons or charges that build up on the metal surface on the metal surface will move towards the ground, will move towards the ground through the earth wire, through the earth wire, through the earth wire. Is there any other thing that will happen? Is there any other thing that will happen? Since the earth wire, the earth wire is a low resistance wire, is a low resistance wire, it will draw, it will draw a large amount, a large amount of current into the circuit, into the circuit, and fuse blows off. Fuse blows off. Simple. In another similar lamp, the fuse is wrongly connected into the earth wire. Okay. The fuse is now connected into the earth wire. Okay. Explain why a person is not protected when the live wire touches the shiny metal surface. Okay. Why is the person not protected now when the uh, wire touches the shiny metal surface? Why? Because now the live wire allows excess current or extra current to flow in the appliance, in the appliance, and this causes an electric shock. However, the fuse will still blow up. The fuse will still blow up. Why? Because the earth wire draws in a larger amount of current, and since the earth wire draws in a larger amount of current, the fuse will blow off. Let's further move ahead to the next question. An electromagnet is used to separate objects that are magnetic from objects that are non magnetic. Figure 6.1 shows the electromagnet suspended from the arm of a crane. State the name of the metal from which the core of an electromagnet is made. Iron. Iron is used to make the core of an electromagnet. The electromagnet is powered by a 220 volts DC supply. The electromagnet is switched on and the current is this. Can you calculate the power? Yes. Power is equals to what? IV. What is current? 38. What is voltage? 220. Can you calculate the power? 38 into 220. This comes out to be 3860 volts. Let's further move ahead. The DC supply is a set of batteries. The batteries power the magnet for 4.5 hours before they need to be replaced. Okay. So the batteries supply the magnet for 4.5 hours before they need to be replaced. Okay. Calculate the charge driven around the circuit. We have to calculate charge. Charge Q is equals to current into time. What is the current in the circuit? Current is 39 amperes. Okay. Multiplied by the time, that is 4.5 hours, multiplied by 60 minutes in each hour, multiplied by the seconds in each minute. 39 into 4.5 into 3600. This gives you an answer of what? This gives you an answer of 31800 joules. 00 coulombs. Sorry, my bad. This is charge, the units will be coulombs. Okay. On a very cold morning, when the electromagnet is first switched on, the current is greater. Okay, the current is greater. Explain why the current is initially greater than 39 ampere. Okay. Why the current is greater initially than the 39 ampere? Because on a cold morning, the temperature is less, the resistance is less. Hence the current would be greater, because current and resistance are inversely proportional. Simple as that. Let's further move ahead to the next question. The power input to a filament lamp when connected to a 12 volt is 20 volts. Okay. State what is meant by power. Work done per unit time. Work done per unit time. Calculate the current in the filament. Power is equals to IV. Power is equals to 20 divided by the voltage, that is 12, comes out to be your current. 20 divided by 12. This gives you an answer of 1.67 ampere as your answer. Let's further move ahead. You have to calculate the resistance of the filament lamp. The voltage is this, the current is this. Can you calculate the resistance? Yes. V over I is equals to your resistance. V is 12, I is 1.67. So 12 divided by this answer, your resistance. Let's further move ahead. The filament in an other lamp is made from thinner wire of the same length and made from the same material. Both lamps are connected to a 12-volt supply. State and explain how thinner wires in the filament affect the power input to the lamp. If your wires are thinner, that means your area is lesser. If your area is lesser, that means what? Resistance is inversely proportional to area. If area becomes less, resistance will increase. If your resistance increase, what is the formula of power? Power is equal to VU square over R. If your resistance increase, power will become less. So you will say thinner wires lead to what? Lead to a greater resistance, and a greater resistance leads to a lesser power. Simple. Let's further move ahead. Okay, let's see this. Figure 9.1 represents the conversion of energy in a mobile phone. The state the form of energy stored in the battery. Chemical energy. State the useful form of output energy from the battery. Always remember, from the battery, which energy do we receive? Electrical. State two useful forms of output energy from the mobile phone. Maybe light energy and maybe sound energy due to the ringing of bells. When the battery is in use, the average current is this. Calculate the charge that passes in a time of 2 minutes. Charge is equals to current into time. Your current is 1.3 into 10 is the power of minus 3. Your time is what? 2 minutes, 2 into 60. So 1.3 into 10 raised to the power of minus 3 into 2 into 60. This comes out to be what? This comes out to be 0.156 coulombs as your charge. Let's further move ahead. Our student estimates the thermal energy produced in the battery when the mobile phone is used and uses this value to estimate the efficiency of the battery. Okay. He measures a temperature rise of 5 degrees centigrade within the battery in a period of time when the useful output energy from the battery is this. This is what? Your useful output energy. The mass of the battery is this, the specific heat capacity is this. Calculate the thermal energy heat needed to raise the temperature of the battery by 5 degrees centigrade. Q is equals to mc delta T. What is mass? Mass was given here 110 grams. This becomes 0.11 kg. What is the specific heat capacity? 830. Okay, what is change in temperature? 5 degrees centigrade. Can you calculate the thermal energy lost? Yes, 0.11 into 830 into 5. This gives you a value of 456.5 joules as your answer. 456.5 joules as your answer. State what is meant by efficiency. Efficiency is what? Useful energy output divided by what? Total energy input. Total energy input. Yes, you can write this ratio as well in the examination with this formula. Calculate the efficiency of the battery. Okay. How will we calculate the efficiency of the battery? Very easy. What is your useful energy output? It was already given in the question. 5200 joules. Okay. So in the numerator, you will write 5200 joules. What will be your denominator? Total energy input. So the thermal energy plus this energy will be the total energy. So 5200 plus 456.5. You can calculate the efficiency in decimals. The value of efficiency can be given in both decimals and percentages. It makes no difference. The efficiency comes out to be 0.92. And if you want to give it in percentage, it will be 92%. Let's further move ahead. Suggest and explain one reason why the value for the efficiency calculated in part 3 is larger than the actual efficiency of the battery. Okay. So the examiner is asking why in actuality the efficiency will be less than the value you have calculated. Okay. Because heat lost to the surrounding. Heat lost to the surrounding as well. Heat lost to the surrounding. And if heat is lost to the surrounding, what will happen? Your energy input increases. Your energy input, total energy input increases. Okay. So what can you say? Total heat loss to the surrounding will is not considered here. If we consider that the total energy input increases, hence your efficiency decreases. Simple as that. Let's further move ahead. A filament lamp is connected to a 240 volts alternating current main supply. Okay. Describe how the output of an AC supply differs from the output of a DC supply. Sketch two voltage time graphs in the blank spaces to help your explanation. Okay. So for an AC supply, how does your voltage looks like? Let's say this is an AC supply. Okay. An AC supply has a voltage that keeps on fluctuating between positive and negative values like this. However, DC supply has a constant value of voltage. Has a constant value of voltage. Somewhat like this. Obviously, if you will draw with a scale, it will look much more neat. You can also describe it for an AC supply. For an AC supply, the voltage or current keeps fluctuating, or you can say keeps changing direction. Keeps changing direction. However, for a DC supply, your current flows in one direction only. Current or voltage flows in one direction only. Simple logic based answer, nothing complicated here. Let's further move ahead. Let's switch to a black pen. The lamp is rated at a power of this and is designed to be used with a voltage of this. Calculate the current in the lamp. Okay, so power is this, voltage is this. You have to calculate current. Power is equals to IV. Power is 60, voltage is 240. What is your current? 60 divided by 240. This comes out to be 0.25 ampere as your current. 0.25 ampere is your current. Calculate the resistance of the lamp. Now you have to calculate the resistance of the lamp. How will you do that? You have the voltage, you have the current, V over I. So V is 240 divided by I, that is 0.25. Your resistance comes out to be what? 240 divided by answer. Your resistance is 960 ohms. Let's further move ahead. A room is lit by 5 of these filament lamps connected in parallels. Is a two advantage of connecting the lamps in parallel rather than in series. What is the first advantage? If one gets faulty, or if one gets faulty, the other lamps keep on running. And what is another advantage of connecting things in parallel? They can be operated separately. They can be operated separately. Let's further move ahead. The 5 lamps in B part 3 are lit for an average of 5.5 hours a day for a year. Electricity costs 0.15 kilowatt hour. Calculate the cost of using these lamps for a year. Okay, so what was the power of each lamp? It was 60 volts. If I convert it into kilovolts, what will it become? 0.06 kilovolts. Okay. Now, can I calculate the time in hours? Yes. 5.5 hours per day. There are 365 days. You will have the number of hours as well. 5.5 into 365. This gives you the number of hours. That is 2007.5 hours. Okay. Now you have to first of all calculate the energy. for 5 lamps. 5 into power into time. 5 multiplied by 0.06 into 2007.5. Let's calculate this. 0.06 into 5. The energy comes out to be 602.25 kilowatt hours. And 1 kilowatt hour costs what? $0.15. So how much will 602.25 kilowatt hour cost? Multiplied by 0.15. This comes out to be $90. So 602.25 multiplied by 0.15. This comes out to be $90. Yep. A student takes the lamp in B to school and connects it in a circuit using a 1.5 volts cell, an ammeter and a voltmeter. The circuit is used to determine the resistance of the lamp. Okay, you have to determine the resistance of the lamp. In the blank space, draw the circuit diagram of the circuit used to determine the resistance of the lamp. First of all, you will draw a 1.5 volt circuit. Then you will connect an ammeter here that will measure the current in the lamp. Then you will place the lamp here. Still one thing is missing. What is that thing? You will have to connect a voltmeter in parallel like this. The voltmeter will give you the value of voltages, ammeter will give you the value of current. You can use both of them to calculate the resistance. The value of the resistance of the filament lamp in this circuit differs greatly from the value calculated in B part 2. State how the resistance value in this circuit differs and explain why it differs. The circuit value or the resistance value in this circuit differs. Why? Because filament lamp is at a lower temperature. Hence what? Hence value of resistance differs, or you can say value of resistance is greater. Value of resistance differs, or you can say value of resistance is, hence you can say the value of resistance is different, or you can say value of resistance is lesser, because at room temperatures the filament lamp have a lesser resistance. Simple. This marks the end of the past paper for practical electricity. If you have any questions, you may ask.